century. Given the Secretary of the Air Force's emphasis on bold thinking and the Chief of Staff's exhortation of every airman an innovator, how can industry contribute to these precepts? What do you see as the greatest impediments to the realization of these tenets? And how can the Department of Defense, along with its partners in industry, overcome institutional inertia and move rapidly to develop the concepts and materials that will successfully achieve that third offset strategy the Deputy Secretary of Defense work endorses? To address these questions and others that are relevant to this topic, we have with us today some of industry's brightest thinkers, finest minds, and successful innovators in their own right. Now, what I'm going to do right now is provide their introductions right up front, and then the panelists will give their perspectives. So hopefully we'll have a little bit of time for questions and answers. First on the dais is Darryl Davis, who's president of Phantom Works for the Boeing Defense, Space, and Security Business Unit of the Boeing Company. In this position, he oversees a $1 billion advanced research and development organization that's delivered some of America's most leading-edge capabilities. Pat Antkowiak is Corporate Vice President and Chief Technology Officer for Northrop Grumman. In this position, he has executive responsibility for developing and executing corporate technology strategy and setting plans and interfacing with technology leaders around the world. James Dorrell is the Vice President of Technology and Product Innovation for Lockheed Martin Aeronautics. In this capacity, Jim is responsible for leading technology maturation and transition for all aeronautics airborne platforms to improve their lethality, survivability, and affordability. Jimmy Kenyon is Director of Advanced Programs and Technologies for Pratt & Whitney. He's Pratt & Whitney's next-generation fighter engine general manager. Retired Major General Mark Matthews, you all met this morning. He's Vice President for Air Force Programs at Raytheon. As a former Commandant of the Air Force Institute of Technology and both the Director of Plans and Requirements at Air Combat Command, and later a consultant to the Air Force Scientific Advisory Board, he's well-versed in technical innovation. And finally, Bob Ashton began working at Aurora Flight Sciences after retiring from the Air Force almost 9 years ago. Aurora's Orion remotely piloted aircraft recently demonstrated 80-hour sortie endurance in a test flight. Bob works with the services and COCOMs to provide innovative ISR capabilities. So with that set of introductions, please welcome these folks to the stage, and we'll get started.
Good afternoon, everyone. I'll try to keep this brief because I'd like to pivot off of what General Welsh said earlier today, and Dave said it so well in his opening remarks, that every airman is an innovator. What we're trying to do inside the Boeing Company is that every engineer, every business person, every supply chain manager, every technologist is an innovator as well. And one of the biggest barriers we have inside a large institution like the Boeing Company is how do we harness that innovative and entrepreneurial spirit. So part of what we do in the Phantom Works really is challenge our people to work on the big problems. In fact, the 7 hard problems that OSD is working on. We have a number of not only our tenured engineers, but some of our young professionals that we've really challenged them to think out of the box. And for those of you that have worked with young professionals, they just think differently than the way, being in the business for 30-plus years, it's pretty fascinating. They just work differently, they think differently. And how do we capture that innovation and entrepreneurial spirit? So one of the biggest barriers we have as a large institution is allowing them to flourish with their ideas and not say no. And that's one of the biggest things we do in the Phantom Works is it's not no, it's why do you think that could work? And then from there it starts a fascinating conversation. That's part of what we do to engage. And when we have those conversations, not only internally, but when we do it with airmen as innovators, we really see some amazing things happen. They turn into ideas and concepts that actually could become reality. And what we do there is we then try to put it into a virtual world of, if I had it, how would I use it, and what could it do? And that's part of the engagement we do with some of the community of interest here, particularly the Air Force. We do it with the other services as well. And then we next step back, if it has a dramatic impact in a capability, in a simulated battlefield environment or air environment? How do you prototype it? What technologies are needed? What technologies are real? What technologies should we be investing in? And that's really what we're trying to do at the front end, to be innovative up front and not tell someone their idea is a bad idea, because there are no dumb ideas. And that's how we've been harnessing the power of innovation in the 21st century. And it really comes down to the people. As the chief said about all the airmen in the room, it is about the airmen, it's about the people, and it's about how we leverage those big ideas as opposed to just saying no.
Thanks, Darryl. A couple of quick points there. One is, General Welch talked about innovation sort of being part of a DNA, and I would say certainly from Northrop's perspective, our biggest asset is our innovation, and it really does depend on the strength of our human capital, and that's our scientists, our engineers, our mathematicians, and technologists of every type and discipline. And we've got to seed it, and we seed it by our great educational institutions, but we keep it sharp, and that's important, by feeding it these bold challenges and hard problems. We need an alignment of bold thinking and strategy in order to achieve that. And, I really like the idea, as the Chief Technology Officer, of looking to the future and seeing something like a third offset strategy. That really does give us that bold challenge and hard problem. It's pushing hard on innovation and R&D to create advantage over and above technology that you can get in the commercial domain, because guess what? It's not good enough just to be rapid adopters of commercial technology. Everyone has this. We have to push our thinking to creating innovative and offsetting advantages. And it's not risk-free. We talked about that earlier. And our budget priorities have to recognize that and balance both the long and the short-range horizons. And as a technology guy here, I feel like, I really need to offer up several areas where I think we can invest to create some of these innovative and offsetting advantages. So first, I wanted to just leave with the idea of secure and open mission systems architecture. And sometimes that idea, secure and open, seems paradoxical. How can you have something that's secure and yet have an open systems about it? But there are ways to do that. And when we fundamentally rest our architectures based on that idea, we can get systems and products that can be quickly and economically refreshed with new technology, and where they can be both trusted and cyber hardened. And second, I know that we need a next generation of sensor and targeting capabilities that utilize machine learning and cognitive systems. There we could accelerate the pace of measure and countermeasure in the battlefield. So you can get out of the acquisition timeline, which is months and years and sometimes even decades, to a real-time timeline, down to nanoseconds or microseconds, using this machine learning and advanced autonomy. Combat clouds, protected comms, all enabled by that open mission system architecture. And certainly, speaking of autonomy, this is a rapidly advancing area, and we've all seen extraordinary and persistent ISR offered. But then we're moving to swarming behaviors for next-generation air dominance and strike. We bring to the table a comprehensive understanding of an experience based on manned and unmanned systems, as well as the value of manned and unmanned teaming. And then finally, in advanced materials, stealth, and scalable manufacturing, there are outstanding initiatives underway, from nanotechnology to additive manufacturing, to advanced composites and highly capable materials, to scalable production lines and centers of excellence for manufacturing to really stretch to meet capacity. These combine to wield a unique, differentiated, and affordable force, and they continue to provide us the kind of advantages in speed, signature, and agility that we need. And as for stealth, at Northrop, it has been a defining quality for us. It's in our past, it's in our present, and it's in our future. Now, there are obvious impediments that can keep us from this goal. We talked a little bit about budgets. Can we get the right balance between the needs now and our future? The R&D priorities, can we strike the right balance to ensure we get real offsetting advantages? And then there's the workforce demographics. You talked about that earlier. Can we engage and excite the next generation of young engineers, scientists, and technologists to our field? And finally, can we undo the gradual shift away from the kind of basic science, research, and discovery that has been at the root of our innovative spirit and engage our human capital, science and technologies, and universities to help us in endeavor? I do believe that we can succeed in this endeavor by building around, again, bold thinking on hard problems that excite the innovative spirit, by engaging and inspiring our amazing workforce, and really embracing this partnership between industry and the Air Force that has served us so well. Thanks.
Thanks, General Deptula, and thanks to the AFA for the opportunity to participate in this panel. At Lockheed Martin and the Skunkworks, we're trying to address that third offset strategy by placing a larger IRAD investment on those lists of technologies, short list of technologies that really drive lethality, survivability, and affordability. And we're also trying to focus on technology demonstration and technology transition. That really is the innovative pieces that we're trying to focus on. And what's driving those investments is our threat-based operations analysis to make sure we measure and ensure that those investments are paying off. We all know that the threats are continued to evolve at a very scary pace, whether it be the air threat, the ground threat. Innovation is going to be mandatory as we look forward, especially into the contested and highly contested environments. And innovation really comes in different flavors, if you will. There's the innovative technologies themselves, things like hypersonics and high-energy lasers and cyber. There's developing innovative ways to integrate those technologies onto our platforms. There's making sure that our platforms can be deployed in a collaborative manner. There's innovative business practices. We even heard this afternoon there's innovative maintenance approaches. So innovation really comes throughout the life cycle of the technology and the platform. For today's discussion, I'll just kind of focus on a couple of examples. So, and I promise Pat and I didn't exchange notes, but open system architecture and open mission systems is one that I want to focus on too. This is a capability that's been developed by the Air Force, and it's innovative both from a cost perspective and a capability perspective. From a capability, it's enabling rapid software reuse. It's reducing regression testing significantly, and it's allowing capability to be fielded at a much more rapid pace. And obviously with the cost side of that is because it's reduced regression testing, maximizing software reuse, it's a huge cost savings. It is a huge enabler for the third offset strategy, and we must continue to leverage that. It's open system architecture is a requirement on our new starts, and we've got to accelerate the implementation of OSA onto our legacy platforms as quickly as we can. Another example is a strike package resource manager, potentially hosted by the Combat Cloud. This resource manager would operate within the strike package of assets and could potentially optimize the sensors, the weapons, the electronic attack, even the cyber techniques that are within that strike package. So as we look forward to that highly contested environment, we've got to be able to have our platforms work collaboratively, and that resource manager will maximize lethality and survivability, and that's what our constructive analysis has shown, and that's what our flight demonstrations have shown. So what's a couple of the biggest impediments or challenges to the third offset strategy? Well, one is today there's no incentive for making these major innovative leaps. And in fact, industry is penalized for that by the way of risk. The DoD is currently very risk averse, and true innovation is going to require risk. So we've got to get to a point where both industry and the Air Force and the DoD can manage risk better and therefore accept risk in a smart way. The second impediment I wanted to talk about is a trend that's developing. And this trend is developing where the government wants to claim all intellectual property by industry. And in many cases, that intellectual property is being used to even level the playing field in some competition. So if that trend continues, I think many of the truly innovative ideas and technologies may not be brought forward and may not help us realize innovation. So we've got to find a way to balance that intellectual property approach as we go forward. So in conclusion, innovation comes in very, very different forms and flavors, whether it be the technology itself or the platforms or the business practices. We've got to be able to innovate in all of these ways if we want to be successful in realizing the third offset strategy. And innovation is really going to take a partnership. It's going to take a partnership between industry and the government to make sure we can realize that. Thank you.
I want to take a step back before I go too much into this, but I think it's important to recognize what innovation is doing for us today. It's really an exciting time to be in aerospace. Before I started working at Pratt & Whitney, and I've not been at Pratt & Whitney for too terribly long, I spent time at OSD, and I had an opportunity to look at the entire aerospace technology spectrum across the services, across the U.S. government, across industry, and around the world. And it really is remarkable, the things that are coming to fruition today. If you want to look at on the aircraft side, we are starting to see composite materials and composite structures finally make their way in a meaningful way into our aircraft. And the services, the agencies throughout the federal government, working with industry, are looking at ways to streamline the certification process and really get those out there much more quickly, much more cost effectively. But we're right on the cusp of that. If you look at hypersonics, this has been decades in the coming, but right now we're looking at the potential to turn hypersonics into real, practical, useful systems that will provide a real warfighting benefit. But of course I am at Pratt & Whitney, and so I want to talk a little bit about what we see in propulsion. I think everyone is familiar with generational leaps in aircraft capability, but every one of those have been predicated on and dependent on a generational leap in propulsion capability. If you look on the commercial side, since the dawn of the jet age, we started with turbojets, then we figured out that if you put a fan on the front, you could do things more efficiently, and we went to the turbofan. And then we figured out, well, if we make the fan even bigger, it becomes even more efficient, and we got the high bypass ratio turbofan, or the high bypass turbofan, each time providing a significant increase in efficiency, reduction in operating costs, and really a substantial improvement in capability. Right now, at Pratt & Whitney, we have a product called the Gear Turbofan that's going to enable the concept of ultra-high bypass turbofans. And what that enables is yet another double-digit improvement in efficiency while significantly reducing noise and emissions. On the military side, everybody knows we're on the 5th generation of aircraft and the 5th generation of engines. Right now, we're getting ready to field the world's most powerful jet engine. A huge amount of thrust coming out of something that size. It's really astounding, and still able to adapt between up and away, conventional flight, and short takeoff vertical landing operations. A truly remarkable improvement in capability, and really a testament to the investment and the time and the money that's gone into technology development, not for a couple of years, but for decades. But even while we're doing that, we're looking at adaptive engines that use a third stream of air through things like the Adaptive Engine Technology Development Program, provide another generational leap in propulsion capability. It's really, really very exciting to see, again, this huge investment pay off. But this has been the challenge. These things don't come about overnight. They come about through years and sometimes decades of investment, of hard work, of people with great ideas, taking those ideas, working through really hard physics problems to turn them into a reality. And the question we face today is, how do we keep that going into the future? How do we harvest this innovation and keep that innovation going for the next generations? And when you look at the situation we have with ever-increasing costs and ever more constrained budgets, that's hard. But first and foremost, what we need to do is we need to have a steady investment in technology development and in innovation. We can't cut the siphon off. And when you have a dwindling budget, it's really tempting to do that because you're not going to need this stuff for 10 years, and you can wait a year, you can wait 2 years, and it's not going to make that big of a difference, but it does make that big of a difference. So we need to keep that investment going, and we need to invest in good work. We need exciting programs and projects for young engineers to work on because that's what's going to bring them into the business, and that's what's going to make them want to do this work. And we need to give them the chance to succeed. We need to allow them to make decisions, to make those hard technical judgments. But that's another kind of an impediment we have is a growing sense of risk aversion, where it's harder and harder to make a decision. You need more and more people to make a decision, and that simply drives costs and it's time, and is a big reason why things take so long and cost as much as they do today. And it also doesn't help us attract those young people and allow us to get those innovative ideas forward more quickly. So we've got to do something about risk aversion. And then, of course, James had already referred to that, and he referred to this as well. It makes a lot of sense in a budget-constrained environment to look at industry more and more and leverage the work that industry has done on its own. But when you do that, you have to think about how you incentivize industry to keep that investment going, because what you do end up doing, of course, we can talk about how we use intellectual property and how we take the different companies' intellectual property and use it so that we can sustain competition. That's a good thing. But by the same token, when you use that way, then everybody starts to have the same intellectual property, and that stifles innovation. By the same token, we've seen a growth in different kind of contracting mechanisms, be they fixed price or cost share types of contracts, which require industry to put skin in the game. And to some extent, it may be appropriate, especially in some cases, for industry to put some skin in the game. But those funds compete with other things like IR&D. And when you start to do that, and you're investing instead of great ideas in industry, but in government priorities or customer priorities, what that ends up doing is, again, driving everybody to work on the same things with that investment. And again, we start to all look kind of the same, and it stifles innovation. Of course, all of those things are done for a reason. It makes a lot of sense why we do them. But we have to think about that subtle law of unintended consequences as we go through that. But it's exciting. We've got a lot of great things going on. We just need to think a little bit harder about how we're doing it so that we can make sure that we sustain this innovation over the long term.
Again, thanks to General Deptula for inviting me to participate in this panel. I kind of figured he must have been scouring the dregs of the barrels since I had the opening and the closing panel today to find someone to round out the panel. But I appreciate the opportunity to address this subject, which is very important to the Air Force, to Raytheon, and to me personally. I just note that after more than 13 years focused on counterinsurgency, the Department of Defense has realized the need to address an extant threat, one from the only peer that can actually match the military power of the United States. As a result, with DARPA, they have initiated a program referred to as a long-range research and development planning process. It has this rather tortured acronym, LRDRP. No one's actually quite figured out how to pronounce yet. Its goal is to highlight and focus new concepts in supporting technology in countering an imminent threat, a threat that was starkly illuminated by the loss of 108 aircraft in just 18 days by America's key ally. Now, if you're not quite sure what I'm talking about, I'm not talking about 2015, I'm talking about 1975. And that's it wasn't called DARPA at the time, it was called ARPA. Had initiated a program, and it had the same acronym, LRRDPP, and the same process, but there was a difference between what they did back in the early 70s and the process that has now been initiated by the Department of Defense. And that difference, when you look back through the report, was from my perspective, was the involvement of industry. Industry just didn't provide inputs, as we have done this week, as a matter of fact, for Raytheon and other companies. Industry was intimately involved in the process. Industry members actually led some of the panels that were part of that process. It was very much a partnership with the government, with ARPA and the Department of Defense. It's also important in the original construct to note that what made a difference at that time were not only the innovations that came out of that, but how the innovations came out. I think the thing that, in retrospect, that you would note is that it required not only bold vision, but bold leadership on the part of the government and on the part of industry. People like Ben Rich of Lockheed Skunkworks, who's generally acknowledged as being the father of stealth, and before him, Kelly Johnson, from the same organization, and others within the Department of Defense and as well as the individual services. Certainly no one individual enables such an enterprise, but one can't underestimate the importance of just having that kind of leadership and that vision to bring something to bear. I had the opportunity to read an interview by John Sculley, who was a former chairman of Apple Computer. You may remember Sculley was the CEO who fired Steve Jobs back in 1985. And in retrospect, Sculley admitted that at the time he did not recognize the important difference in leadership that's necessary to shape an industry as opposed to just be competitive in the industry. When you're only trying to be competitive, you're worried about your stock price, about bookings, about margins, because if you don't pay attention to that, you're gone. But if you really want to shape it, you're willing to take those kinds of risks, and you're able to convince your board of directors, your investors, and the people, importantly, that work for you, you infuse them with that vision. And sometimes you have to do it in a way that involves some bloodletting, such as what Steve Jobs did when he returned to Apple in 1997. He not only brought a vision, but he had to reshape Apple Computer to take it along that path that ultimately led it to be the first company in history to be capitalized at $700 billion today. I think we see the same thing in defense, that today one of the biggest impediments are the lack of incentives, the lack of risk-taking that we've all talked about, the willingness to allow risk to enable bold leadership, bold vision from both industry and from the government and from the services. So the question I would ask today, who is that next leader, both in industry, in the Air Force, in the Department of Defense, that's going to embrace an idea, call it a conspiracy, and we can be co-conspirators together to infuse something, whether it's hypersonics or directed energy or that very special thing that Raytheon is working today is going to change the future tomorrow, that thing that I'm not going to talk about.
Well, I am going to talk about some of Aurora's products. One of the innovations I think that happens, we've alluded to it, is in small business we have innovation happening all the time. So I'd like to at least take you through a little bit of an overview of who is Aurora. We've been on the cover of Aviation Week, sometimes a hallmark of innovation itself. We are an autonomous aviation company. We have been around for over 25 years, and the way we describe innovate or define innovation is young, very high-quality engineers. The STEM program is a big part of what we do to bring in engineers at the high school and college levels. And then we try to incentivize them and allow them to kind of do their own thing and research and bring in new capabilities. Yes, they play with SBIRs. We do a lot of work with DARPA. Some of those culminate with a long-endurance flight that General Deptula alluded to on Orion, 80 hours in December of last year out in California. But those are all exciting for our engineers to see, exciting for all of us to see, exciting for the industry to see. And some of the things that it takes to do that innovation are unique maybe to a company like Aurora because we're privately held and we can experiment a little bit more. We have a little bit more flexibility in the confines of a privately held company. But they apply to larger companies, but they also apply to some degree to the DoD. And as we are allowed to innovate, as we've alluded to, take risk, that's one of those forms that we see technologies do the disruptive technologies and game-changing technologies across the years. And we certainly need to see those as the time marches on with sequestration or budget constraints. Some of the products that Aurora has done in innovation over the last 25 years, you may have seen, maybe not, unless you're in the unmanned systems community. Two of the core competencies of Aurora are autonomous aviation and complex composites, and you'll see those in each one of our products. As Dr. Kenyon alluded to, complex composites are what make lightweight structures stronger and certainly enable some of these technologies to be born into a solar-powered airplane like Vulture, a DARPA program from years ago, to the concept to fly for 5 years, and we were part of that early phase competition. Maybe another that you would have seen called Excalibur, where a VTOL-capable unmanned aircraft, yet high-speed capable, something like a V-22 Osprey, down to the work we do with Sikorsky to support the next generation of heavy-lift helicopters for the Marine Corps, and certainly the Orion aircraft, and I'll talk about that just in a moment as well, down and into space satellites, small basketball-sized spheres, they're called, work we do with NASA to help work with high school students and colleges to develop autonomy in space, and we certainly collaborate with NASA to make that happen. But those are all examples of innovation, so pictures help us to tell those programs and many more like them. The idea of autonomy is certainly necessary when you start talking about long-endurance flights. So autonomy for the Orion aircraft is designed for multiple-day, multi-int, and the way we look at innovation is to integrate several of those aspects we've talked about of risk, using SBIRs, in fact, using different technologies, open architecture and modularity. But at the end of the game, you need to have autonomy so that you're less manpower intensive, because we can't rely on manpower that's too expensive. We can't afford the life cycle costs. And we certainly can't afford to have pilots in the cockpit in every mission, these dangerous, dull, dirty, dangerous types of missions. So the Orion is on its way to demonstrate further in the missions and applications that are necessary for persistent surveillance. It's a buzzword. The Chief alluded to how we need autonomy and we need to take risk in that world. It's alluded to in several of the policies that you'll see at the Department of Defense, the new 5000 series, the S&T plan for the Air Force, and we certainly want to leverage the technologies that are coming out of the commercial sector as well, in the composites world especially, and propulsion world. So we tried to do that on the Orion program, and as we see that mature and potentially deploy to support our national security interests, the Orion is one of those examples that we believe innovation was critical in making it get to this point. And so in our perspective, my perspective, the leadership, as we've each asked for, is we need leadership, we need risk-taking, we need champions that are able to move those ideas from just a concept, a piece of paper, into actual implementation and design build. Where does that come from? It comes from multiple sectors. Sometimes it's persons that are political appointees, sometimes it's careerists, but we certainly need to leverage that and ask for that leadership. The way it keeps on coming about is sometimes the words describe rapid prototyping. That's certainly part of the new 5000 series, rapid prototyping. It's part of the Secretary's strategy, rapid prototyping, and in ways where you might try it till you like it, and then if you like it enough, you'll buy it. It doesn't mean you're committed to programs of record. It doesn't mean you're a 30-year life program. In many of these fast-moving technologies in autonomy, that the life of the technology may be just a few years, not a dozen years, but a few years. And certainly, we have to be engaged. The DoD has to be engaged with industry. We have to look across industry, not just defense-related. And I think that's happening more and more as we have fora like this that allows those opportunities. A big part of it is resisting the temptation to say no, or because it's new, to resist the temptation to reject the technologies. But certainly, it's all about building relationships with industry and across including academia, and certainly within the Defense Department.
Okay, well, thank you, gentlemen, for those excellent insights. We have some excellent questions from the audience, so let's hear what's on their mind. Here's a general question for the audience, I'm sorry, not for the audience, but for the panel, that I think a lot of people will be interested in. How do you make innovation a culture in a very large organization?
I'll start. Some other people can weigh in. Within the Skunkworks, we really break it down into very small, empowered teams. So we try to purposely keep it small. We keep their goals, their objectives of what they're working on to a minimum. And then I think Darryl said it earlier, you don't reject any idea. Every idea that comes forward is valued, is weighed, it's looked at. I think you have to have that culture where success is rewarded, but failure is not penalized, and tolerate maybe is not the right term, but we have to be able to fail and learn from those shortcomings and then implement those as we go forward. But I think it's very small, empowered teams that help us get that done.
James, that was great comments. In fact, very similar to what I was going to say. In fact, I would take a slightly different perspective here. While things may not work out the way you thought they would when you empower a team to do something, there is no failure because you've always learned something when you do it. And the cool part with young professionals is if they don't get the chance to do it and we don't empower them to do it, they won't be willing to. We use the word risk. To me, it is not risk. What's the risk if we don't let people do it? What is when we say it didn't work out, is it a failure? It absolutely isn't, because the young professionals have learned how to do things. We've empowered them to do it, and they will go on to be the next great scientists and innovators in this industry. So the culture that we've tried to create in the Phantom Works is, once again, to empower people, find those projects. Some of the tools that we're using internally, which I wouldn't be surprised to hear from the rest of the panelists, is some of the crowdsourcing things we're trying to do across the Boeing enterprise, not just inside the Phantom Works, but across the 150,000 plus employees of the Boeing company, which is a global company. So how do you leverage that entrepreneurial spirit, and allow people to crowdsource and come back with better ideas, and then give them the opportunity to prototype it, whether it's virtually or with real technology?
That's great points. And what I would add is that there's huge value in the big companies because there's value in a broad range of solutions, a diversity of opinion, bringing together problem-solving teams that can look at things from so many different aspects, and then valuing the folks who are on that team. We've got to make sure that they understand the value that they bring to our organizations as well as the department, because it's all part of reinforcing this idea that an innovator is someone who's important to the company, who can take risks on behalf, will be rewarded, and will be fed hard problems and the kinds of teams and frameworks and management capabilities that will support them over the long run.
I think all of the comments so far have been spot on, but I would add just two things. Leadership. There's a conscious decision that has to be made within a company or within a government organization that this is important and we are going to do it. And that's just a leadership decision that you have to make. But then once you make that decision, because by the way, you're going to have to defend that decision, it's important to recognize what innovation has done for your company, what innovation has done for your government organization. Where did this go? Even the failures that we learned from, what did we learn and how did we use it? But it's important always to understand, looking at the products you have, looking at the systems you field, where did that really come from? Where did that innovation come from? And it's never a linear path. It never works out exactly how you thought it would. But it's important to go back in hindsight. It's always 20/20 and figure out where it came from and recognize that.
Sorry, Jim. So I actually took the question as a large organization being the Air Force. And I would say that one of the aspects of the Air Force Research Lab has used risk. The DoD uses risk at Rapid Fielding Directorate, now called the Enduring Capabilities Office, that does JCTDs. That's how the Orion program was born several years ago, was a study and then a JCTD that AFRL managed. And I don't know if General Masiello is in the audience, but that's one of the things that I think recognizing having excitement and passion in your younger workforce is important for the DoD as well as industry. And I know Darryl mentioned it as well. That's how do you incentivize that? How do you keep them excited? Allow failure. That's a good way of doing that, and that comes through leadership. You're right.
Okay, very good. Mark, you wanted to add or no? Okay. Given the hour, we'll make this the last question. Although I do want to applaud the audience's questions and all of you for sticking around for this very, very important panel. And if this isn't your question, please come on forward and grab these folks after this, or perhaps at the bar. So here's the last question. Is the acquisition community and the Department of Defense striking the right balance between risk and cost? If yes, where can we improve?
No. I think part of the challenge we have is, as industry innovates, and I think it was said by some of the panelists here earlier this afternoon, is the system is not ready to respond to some of the innovation that industry can bring forward. It doesn't matter whether it's a innovative product, could be an innovative business model, could be an innovative support concept. The system is not wired to react to innovation. So hopefully with the third offset strategy and some of the things that AT&L is trying to do, we'll find ways to innovate with the business practices as well as with the ability to tolerate risk, and at the same time have a way to do that in partnership with the department. It was said many times by my compatriots here, there is no risk-reward opportunity here. If we risk our resources to do something and there is no payoff for it, then what have we accomplished if the system can't respond?
Yeah, I agree that, there's the risk aspect has turned to such a degree that it's really hard to bring innovative solutions into ongoing acquisitions because of the constraints and around the costs. Really tend to drive, you have to have almost a completely risk-free solution offered at the time when you build your proposal, that it just makes it difficult to lean forward. And I would say that there's an element of patience and partnership that goes on with the customer communities that we would want to deal with that would facilitate, the understanding that if we take risks, we're going to fail. And that failure is going to cause, issues in the program management. And so what we need to do is also build in a strong risk management process as we execute our development programs to ensure that we always have fall forward and fall back mechanisms to allow us to address that risk and reward the innovation risk that we want to take.
I completely agree. The answer to the question, I think, is no. The one thing I would add is that at lower TRLs, I am seeing some acceptance of risk with DARPA and with AFRL. But as we mature those technologies up the TRL spectrum and it becomes inherently more expensive to mature those technologies, that's where I see no tolerance for risk whatsoever. And like several on the panel have said, if you don't have a zero risk approach, it typically does not go forward.
Again, the answer is no. It's fundamentally no. The issue you run into here is that one of the reasons we've become so risk averse is because things cost so much. The problem with that is as you become more risk averse, you're going to put more and more requirements on there to reduce risk. More and more eyes have to look at it. More and more processes you have to go through. In large documents, you have to check all of the boxes off to make sure that you have absolutely uncovered every risk before you can make any decision to go forward. Well, all of that costs something. All of that takes time to do. And then you add that cost and you add that time, and guess what? Now it's more expensive and it's more critical for you not to have any risk because it's just that much worse. And it becomes a spiral that feeds on itself. And that's where I think we're a little off track. We are seeing it, so I'll disagree a little bit with James because we are starting to see that certainly in the propulsion side, even starting to get down into some of the lower TRL things. And when you start seeing that happen in the lower TRLs and we're doing science and technology programs where failure is a big deal, that's just hard to do. And obviously we want to work at that. We all want things to be successful, but as Darryl said in response to the past comment or past question, we learn in our failures, and it's how you recover from failure often that is more telling than how you celebrate your success. So taking risk early, there's a right balance. There's a time at which risk is just not acceptable. But early in the development process and early in the innovation process, when you're looking at really new ideas and you're trying new things, we have to be able to take risk. One approach you do to deal with that is something called fail fast. If you're going to spot the problem, put it on the line and get to the problem fast. And that's a good way to do things as well. But we need to be able to take those risks. and celebrate failures from the learning we get, and then get the risk out for later on when things really do become more expensive and more critical.
I guess it would be no surprise for me to say no. I'll go back to what I said in my remarks. I think the way you overcome that, the way I've seen it overcome in the past is, again, develop these co-conspirators, I call them, inside the service, inside the Department of Defense. You know, President Reagan was a guy that championed the idea of Star Wars, and a lot of people called him nuts for doing that. But it is remarkable to see that we are actually have evolved to the point where we can develop a credible missile defense because he had a vision and he was willing to champion that idea. And it infused the nation. It gave a sense of hope where before there was no hope, this ridiculous idea of mutual assured destruction. What a crazy way to defend a country. He said, this is just stupid. Let's use a little common sense here. And sometimes you got to have people that will stand up to the system, to the bureaucracy, to the 5000 series, and they'll say, you know, we're just not going to go do this. The country needs this kind of capability. We're going to take risk here. I know this isn't improving, but this idea is bold enough that it can really change the equation. And if you embrace that, then you can move forward beyond low TRL levels. Now, it doesn't get at a lot of the nuts and bolts of the things we do, and we still need to revise our acquisition processes, get away from LPTA, which is anathema, to innovation. But I do think that if you can wrap your programs around these big, bold ideas and carry that vision forward to the American public, whether it's the SecDef, a service chief, or perhaps even the president, that you can move forward.
So the one part of the equation we have a hard time talking about is Congress. Will Congress let you get away with some of the risks and failures? I don't know. But I think the new 5000 series, the better buying power approach, if we actually do walk the talk, that'll be critical. If we are willing to